Chapter 5, exam review. So first question we're going to look at is a word problem. It says a weight attached to the end of a spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the watch reads 0.4 seconds, the weight first reaches a high point 50 centimeters above the floor. The next low point, 30 centimeters above the floor, occurs at 1.8 seconds. Now, from all of that, we are able to come up with an equation. And this will be a sinusoidal function. So it'll be a sine curve or a cosine curve. Anyone know what the maximum is? What's another way of saying max? The high point, 50 centimeters. So if the high point is the max, the low point is the min, and the low point is 30 centimeters. We cool with that? Do you know where the sine axis would be? The sinusoidal axis is halfway between the max and the min. So you probably know what it is just by looking at those two numbers. What's halfway between 30 and 50? 40. But to get it, this is what you would do. You add the max and the min and you divide by 2. That equals 40. So the sinusoidal axis would be at y equals 40. And that's actually equal to the vertical translation. So now I know that k is 40. Because I'm trying to come up with the equation. My equation would have to go in this. So it'll either say sine or cosine. Comes up. So I know the k values are 40. Anyone know what the amplitude would be? That's the distance from the sinusoidal axis up to the maximum or down to the minimum. From 40 to 50 or from 40 to 30, what's the amplitude of each wave? From 40 up to 50 would be 10 units. That means that little a could be a plus or a minus 10. Now, how do I know which one it is? How do I know if it's positive 10 or negative 10? Well, think about how this goes. All right, from 0.4 to 1.8, it goes from a high point to a low point. So your curve is going to look something like this. It would be at a high point, then at the sinusoidal axis, then at a low point, then at the sinusoidal axis, and then back to a high point. What type of curve is that? Sine or cosine? It's a cosine curve. And with this cosine curve, so I know it's going to say cosine, is the a value a positive or a negative? Look at the board here. A is a positive. That means that little a would be a 10. So I know k and I know a. To get the period, I have to take this time right here, 0.4, subtract it from this time right here, 1.8. But that's only half the period to go from max to min. 1.8 minus 0.4. If that's only half the period, how do I get the full period? I double that. P is going to equal 2 times 1.4. P is going to equal 2.8. Cool? Now, the period doesn't fit in the equation. It's the B value that fits in the equation. B is equal to 360 over P. You could call that 3,600 over 28. And then divide both of these by 9. All right. Sorry, not 9, by 4. That'll give you 900 over 7. If you wanted to write that as an approximate value, 900 over 7 or 360 divided by 2.8. Doesn't matter how you put it in. 128.57 or 5714. That's fine. That's my B value. Most people are going to do this one. Yeah? Anyone remember what the H value is? What the phase shift or the horizontal translation? What number is it? It's the first time given. Like, I really don't care what's happening between 0 seconds and 0.4 seconds. So when it comes to the equation, I would write the following. Y equals. What am I going to fill in for my A value? What's little a? 10. Should I write sine or cosine? Cosine. And then I'm going to open a bracket. I'll put the 900 over 7 or the 128.57. If you want to round it, that's great. X minus, I'll fill a 0.4 in here. I'll close the brackets twice. And then I'll add my K value, which is 40. So I just filled in those parameters. Okay. It often asks you with these to make a sketch of that curve. I'll show you how to make a sketch in the next question. You might also write this also instead of y, you might put h at t because the height is a function of time. But that is the equation, and you could replace the x with a t. So you could write it like this. Not x, go with t for time. How do I answer this question? What does this represent right here? Is it a y value or an x value? A height or a time? It's time. It's the x value. So if you wrote your formula like this, you could write h at 17.2 is going to equal 10 times the cosine of 900 divided by 7 multiplied by 17.2 minus 0.4 plus 40. And we can pump that all into our calculator. Now, you know that the answer has to be some number between the minimum and the maximum values. Like it has to be a number between 30 and 50. It can't be higher than 50 and it can't be lower than 30. So here's what you do. If you have a forward calculator, you can just start right at the beginning. 10 cosine. My calculator opens a bracket for me. I'll put the 128.57, left bracket again, 17.2 minus 0.4, close the bracket twice, add 40. And what do we get for an answer? Anyone have an answer that they're willing to share on the World Wide Web? Go for it. Take a chance. Okay. There you go. 50 centimeters. Attaboy. The reason it's not 50 exactly because I rounded. I put the 128.57. If we use the 900 over 7, And then open the bracket again, 17.2 minus 0.4. Close the bracket twice, add 40. There's my 50 right on. Look. 50 on the, you use the 900 over 7. You use an exact value. That's the benefit of using this instead of this. Now, really, 49.999, we'd round that to 50 anyways. Everyone cool with that? And I put the units on it. You would have to say that, like at 17.2 seconds, the spring would be 50 centimeters high. I think it was centimeters, yes? Yep. So it's at a maximum again. Question number 2 from chapter 5. This is also a chapter 5 question. It says graph the following sinusoidal function. They just want to graph one period. So I'm going to put this in standard form. I'm going to pick out A, B, H, and K. I'm going to make a mapping rule. And then I'm going to transform my key points. And I'm going to fill in this chart. What would my equation be if I put it in standard form? How would I get rid of the divide by 2? Times it by 2. And on the right-hand side, I would multiply the A value and the K value. So negative 3 times 2 would become negative 6. What am I going to factor out in here? 5x minus 100. Factor out a 5. I would leave x minus 20 degrees. Close the brackets twice. What should this become? Negative 2. Why does it become a negative 2? Because I doubled it. I multiplied A and K by 2. Fair? Let's pick out our parameters. What's little a? Negative 6. That means the vertical stretch factor is 6. That means the amplitude is 6. The B value is 5. The horizontal stretch factor is 1/5. What's the period? (360) divided by B. 360 divided by 5. What is 360 divided by 5? What's the H value? 20 degrees to the right, to positive 20. When you take it out of the brackets, you change its sign. What's the K value? And that would mean the sine axis give myself a little space here, would be at y equals negative 2. If I were to make a mapping rule, it would look like this. 1 over b, 1 over 5 times my x value. Then I would add my h value, add 20 degrees. And then I'd go comma, and I'd write a times y, negative 6 times y plus k, plus negative 2, so I'm just going to write minus 2. Anyone remember the key points for a sine curve? It's in degrees, right? So I'll go 0, 90, 180, 270, and 360. These are all in degrees. Anyone remember what the sine of 0 is? The sine of 90 is 1, the sine of 180 is 0, the sine of 270 is negative 1, and the sine of 360 degrees is 0. Those are your key points for a sine curve. How did I know it was a sine curve? Look, it says sine right there. Now let's transform them. What would my new points become after I transform? It's easiest to do the y values first. I got to multiply all of these y values by negative 6 and then subtract 2. So start with a 0. Plug that in here. Negative 6 times 0 would be 0, minus 2. this would become a negative 2. So would this 0, and so would this 0. The 1, if I plug it in there, negative 6 times 1 is negative 6 minus 2 would give me a negative 8. A negative 1 gets plugged in here. Negative 6 times negative 1 is positive 6 minus 2. This becomes a 4. For the x values, I got to divide those all by 5 or multiply them by 1/5 and then add 20. If I fill a 0 in there, 0 divided by 5 is 0 plus 20. This would give me 20 degrees. What's 90 divided by 5? 18. 18 plus 20 is 38. 180 divided by 5. 36 plus 20, that's 56. They're going up by 18 every time. 18 more. 18 more. What would the next number be? 74 and then 92. You with me on that? Okay. You could just check this. You could go 270 divided by 5. That gives you 54, and then you add 20. There's your 74. 360 divided by 5. 72 plus 20, 92. When it comes to drawing, this is what I would do. I'm going to go 2, 4, 6. And then I'm going to go down the y-axis. Negative 2, negative 4, negative 6, negative 8. Along the x-axis, let's put a little break in the curve. I really don't care what's happening between 0 and 20 degrees. So I'll just kind of scrunch that information out, and I'll go at 20, and then I can count by 18s from there. I can just go 38, 56, try and make these equal, 74, and 92. And those are all degrees along the x-axis. And when I plot these, watch, I'm going 20 degrees to the left, down 2. 38 degrees, 20 degrees to the right, down 2. 38 degrees to the right, down 8. 56 degrees to the right, down 2. 74 degrees to the right, up 4. And then 92 degrees to the right and down 2. And I'm going to join them with a smooth curve. Try and round those and make them into a nice wave. No points. And what would happen at this? Like, would it hook back up here? Or hook down here? If you're not sure, just put your arrows like this. But know that, like, that's not the maximum or the minimum. That's, if I kept going to the left, it would go up. And if I kept going to the right, this is going to keep coming down. So it's a sine curve. That's what it would look like. Let's fill in our chart. What's the domain of this blue curve? If it goes left forever, right forever, domain would be x such that x belongs to the real numbers. In interval notation, you could write that like so. Negative infinity to positive infinity. What about the range? Y in the middle, greater than or equal to your minimum. Less than or equal to your maximum. Y belongs to the real numbers. In interval notation, that would look like this. Negative 8 to 4. Cool? The graph proves both of these things. The domain, x belongs to the real numbers. It's going left forever, right forever. The range, it's got a high point of 4 and a low point of negative 8. Y is greater than or equal to negative 8, less than or equal to positive 4. What's the amplitude? We wrote it down up here. It's the absolute value of little a. 6. The period, we wrote it down right here, 72 degrees. That's the change in x corresponding to one cycle. If I took 92 and subtracted 20, I'd get 72. That's the period. What's the phase shift? It's 20 degrees, and I'll put the direction. I went to the right. The vertical translation, it's my K value. It's down 2. I'll put 2 down. The equation of the sinusoidal axis, y equals -2. And the mapping rule, I'll just draw a big arrow up here. There it is. Any issues or concerns with that? There's chapter 5, Cole's Notes version. All right? We'll work on your review. For